So hey everyone, welcome back, and today we are going to discuss another contest. And thanks for showing the love on the last video which I have posted on the last weekend, right? And so today we are going to discuss another contest, but in this particular video we are going to discuss both the contest, the weekly contest 505 and the bi-weekly contest 184. So without wasting time, let's get started. Let's start with the problem statements, like what the problem is and how we are going to think about the solution, right? So start with the first problem. This one is already like always easy as usual, right? So what the problem is, sum of compatible numbers in range. Got it? You are given in two integer n and k. A positive integer x is called compatible if it is satisfy both of the following condition. Absolute of n minus x should less than be equal to k, and the AND operator with n should equal to 0. Return the sum of all the compatible integer x. Okay, so you can write it what they are asking us to do. So the question is quite simple, right? The only thing which is different apart from the easy problem is that you actually don't know about the ending range of this particular problem, right? Because when I solved for the first time, I use this particular range, right? But I got a wrong answers. Then I got to realize that okay, what will be the end range will look like. So you also should need to take care of that as well, right? So that you don't do those mistakes. So what I have to do, we just have to start from the one, right, until end to the end range whatever we are selecting, and at every point we just have to check this condition. If it's satisfied, then I simply add that particular value inside our answer. So this is what we are doing over here is right. So we are iterating from 1 to the end. I have taken at 1000 because there is a reason behind it, right? You can also figure it out. I figured it out by myself. You can think about what what thing get wrong, like at what point, so that you also got to know that okay, in which scenario you have to think about certain situations, right? And after that I'm just checking one condition that okay, if it satisfy both the condition, that means I have to include that inside my answer because I have to return the summation. So this is the first problem of the weekly contest is look like, and it's pretty easy problem, right? Let's talk about the second problem. It is also pretty easy, right? It is like a standard problem, I would say. If you know about the recursions and if you know about how to generate the substrings, then it is just a cakewalk for you because it's just a little variation, not that much. So let's understand the problem. You are given a two integer n and k. Got it? The cost of a binary string as is defined as the sum of all indices 0 base such that s of I is equal to 1. A binary string is considered valid if it does not contain two consecutive ones character. Its cost is less than or equal to k. Got it? Return a list of all valid substring of length n in any order. So let's see the test case for the better understanding of the problem, right? So we have a n, like we have to generate all the string with the length n and make sure the cost should be 1. And how we are actually calculating the cost, we are calculating the cost in such a way that, let's say, if the string is 101 and if you mark at 012 012, then cost is if nums of I or whatever is equal to 1, then cost is going to be I, means the index of that particular number, index of that number. So this is what we have to do over here, right? So this is what they are doing, right? So if you see, in case of 000 the cost is 0, in case of 100 the cost is 0, in case of 101 the cost is 1, and in case of 001 the cost is 2. Why? Because 1 is occurring at the second index, and in case of this the index the value is this, right? So this is the whole idea behind this particular problem. So you see, this is standard. What you have to do first, let's say I ask you to, what you have to do, there are just two steps. First, generate all the possible substrings which are possible with the n is equal to 3, and make sure the string only contains 0 and 1, right? Make sure about this particular fact, right? So the string is only going to contain 0 and 1. So what we have to do, we just have to generate all the substrings. And the another thing is, while generating, we just need to take care of the cost, right? If it is less than or equal to k or not, right? And if it is satisfied both the condition, that means the particular thing is going to be a part of our answer, right? So this is the standard problem and how I have approached it. So let's see the code. It is pretty simple, right? So I just created an array list because we have to return it inside our answer, and I have created a function, solve function. What the parameter I am passing, the string which is going to contain all the substring, the n k answer which is going to store all the answer, this one for the cost and this one for the indices, because with the help of indices we are going to calculating the cost, right? Because this is what they are asking, right? So this is the base case, which means if the string which I have formed is equal to the length of n, then I just simply check if the cost is less than or equal to k, right? If it is, then simply stored inside our answer and return, right? And after that, at every point I'm just it is just like standard pick and non-pick like kind of recursion, where at every point I'm just picking 0 and calling the solve function, and I'm removing the 0. Now it's time to pick 1, but make sure whenever you're picking 1, it should not already have 1 previously, so that we avoid the condition where we are actually picking the consecutive elements, right? And after that I'm just checking for the 1 as well, and just simply iterating it like this. So this is the whole problem, and what would be the time and the space complexities of this particular problem is like. So the n is going to be 12, right? So it is like at every point you just have 2 to the power 12 number of possible cases. So this is 2 to the power 12, time complexity is 2 to the power, right? So at every position you have this number of possibility, right? And the space complexity is 1, because we are not taking any extra space, but and we are also not considering the stack space as well, right? So this is the second problem. Let's move to the first problem of biweekly contest. This is you are given an integer n, return a true if it's a binary representation contains exactly one pair of consecutive set bits, and false otherwise. Okay, so let's see what they are asking. You have given a number n, right? Let's say you have given a number n as 6, convert it into binary, and if you see, it only contains one consecutive pair, right? So this is a part of our answer, so we will simply return true. But let's say if the number is like, then it contain two consecutive pair of ones, right? Which is not what we want, so we simply return false in this particular scenario. So this is straightforward. We don't have to do a lot of stuff. We just have to like iterate from the left to right and simply count the number of consecutive, right? If we at any point if we get 0, then we like what I have done is, let's see through the code for the better understanding. Like what I have been doing, I am counting all the consecutive ones and I'm incrementing the pair value, right? Why? Because let's say if the string is 1 1 0 0 0, right, 0, right? So I am just checking if the pair is like, if they are equal, then thus I'm simply incrementing the value of pair is 1, right? And if at every point I did not get any value, that means I don't have any pair, right? So that's why I'm counting it over here, and I'm just checking if pair should be 1, right? Because in this particular case the pair is always be 1, but if the case become like this, then the value of pair is become 2, right? In that case it will always return false. So this is the whole idea behind this first problem, which is a standard or straightforward problem. You will understand it more better if you write the test cases by your own self, right? That will give you a good idea about the problem, right? The interesting problem, it is a good problem, right? So what they are asking, you are given an integer n representing the n light bulbs arranged in a line and index from 0 to n minus 1. You are also given an integer of brightness and a total integer array intervals, where interval I should be equal to start and I represent an inclusive time interval during which the lighting requirement must be satisfied. Got it? At each time unit, every bulb can be independently be either on or off. A bulb that is on eliminates its own position and its adjacent position if they exist. The total eliminations at a time unit is the number of eliminated positions. Each position is counted at most once. For every integer time unit covered by at least one interval in intervals, the total elimination, okay, the description is too long, and the another thing is that description is too poor. Like I also not able to understand when I'm solving for the first time. So LeetCode should be improve it, because I thought the problem is medium but the description is hard, right? It will become really difficult for the people like to actually understand what the problem is trying to say, and that will become really difficult for them to actually understand, right? So let's see with the example like what they are saying. So basically if I explain in a simple word, they have mentioned that the value of n which, let's say 5, which represent the bulbs in a row or in a number line, you can say, which means, right, we have a bulbs, right? And what they are mentioning that if we on a particular bulb, then it will lighten both its neighbor, right? And similar for the other, if we on this, then it will lighten the both the bulbs, right? So what we have to do, we just have to find how many minimum energy we require, uh, energy required such that all the bulbs are lightened at that particular time duration, and make sure what and how many energy is going to be take. If we on 2 bulbs, then the number of energy is going to utilize its 2. So this is what exactly the problem is saying, right? But if you see, this is like too much, it is a completely a poor description. I also not able to understand when I was solving the first time, right? And after that right, so I just sorted a list. Why? Because we have intervals, and I'm trying to because you see, whenever you have a problem related to interval, so always make sure to sort them on a certain condition and try to merge them and then try to figure out the solution, right? That will help in most of the problems. So what the same which I have been doing over here is the cover time, what is the time which we are going to require, right? And just pick the first interval, and I'm just performing the merge operation. You all know how to do it if you have solved a various problem related to merge intervals and other stuffs. If it is less than equal to n plus 1, then I'm simply incrementing the n, which means we have merged the interval. Otherwise it is completely a new interval, then we are simply updating our starter and value, right? And after that is simply counting the cover time, how many time we actually require to complete that particular interval, right? So this is what we are storing over here. And after that when we are done with this, then we still have the last interval, right? Because we haven't processed that, so for that we simply process it over here and include it in our cover time. And after that, how many number of bulbs we needed. So if you see, based on the condition which I have mentioned, if you have bulb like this, so if at any point if this bulb is going to it is on, then it is always going to cover 2 other bulbs as well, which means it is always going to be on a 3 bulb, right? So this is what we have what we are doing over here is brightness plus 2 which we have given, and we are dividing it with the 3, right? We are doing it to reduce the overflow of the number, and we are dividing it 3 because always whenever there is a bulb on, then there is always be a 3 bulbs are going to be on, right? And after that we are simply returning the bulb needed multiplied by the cover time. So this is the actual amount of energy which we required. So this is the whole problem. It might be a little difficult for you to understand specifically this particular part, because this is the straightforward, right? You don't have to do a lot of stuffs. You just have you just need to be like a little understanding of intervals, right? So this is the this is the second problem of the biweekly contest. So I hope you guys are able to understand these solutions, and if you are able to understand, do let me know in the comment section. If you have any query regarding problem solutions, do let me know in the comment section. I would love to make a video and love to help you out there, right? And if you have any suggestion regarding the videos regarding the topics in which I would make content in upcoming days, then do let me in the comment section. I would love to make video on that as well. And bye bye, take care for that, and keep grinding, keep learning. Yeah, this is it. Bye bye, take care.